Morning, everyone. Thanks for joining us this snowy morning, maybe taking a break from shoveling or plowing out there. My name is Buzz Sirwillow. I'm with the Solid Waste Management Program with the Department of Environmental Conservation. And this webinar is on managing ash material at solid waste facilities. Even though we sent it out to all the facility owners and operators that manage wood waste, we were thinking that this could be informative for DPW people or Parks and Rec, local Parks and Rec people. So hopefully there are a few of those folks on the line. I think the genesis for this effort between my department and Forest and Parks was the discovery of emerald ash borer in February of 2018 in Vermont. And that got us to thinking that when the bugs really start to, tree mortality starts, that a lot of this material may end up in solid waste facilities, particularly from the urban areas. And so we have started this effort of outreach and trying to partner with solid waste facilities to slow the spread of the emerald ash borer. Before we get started on the presentation, just a couple of logistic things. We want this to be about a half an hour presentation, so maybe 25 minutes worth of slides and discussion, and then maybe 5 minutes at the end for questions. So feel free to type in your questions at the box on the top right corner of the screen, and we'll get them to the end. And if we don't get a chance to get to everybody's questions, or you have questions later on, there were my contact information in the original email, and it'll be at the end of the presentation. Feel free to, at some point in the future, send us any questions that you have. We will be recording this presentation for people who couldn't make it or want to see it again, or can be passed along, so we'll let you know when that becomes available. So I guess we can get started. Our presentation today, our presenters are Paul Frederick, who's the Wood Utilization and Wood Energy Program Leader with the Department of Forest, Parks, and Recreation, and Mike Parizio, who's a Forest Health Specialist out of the Rutland office of the Department of Forest, Parks, and Recreation. So I'll turn it over to Paul right now.
So just very quickly, what we're planning on covering this morning is kind of a short history of what of EAB, talking about the biology of the insect, how the insect has spread to date, how we are working to help slow the spread of EAB, and how you folks can partner with us to assist in that effort. And we'll turn it over to Mike now, who will cover the biology and some background on the insect.
Mike, we can't hear you. Can you start over again? We're still having trouble hearing you. We can see your screen, but we cannot hear you.
Can you hear me now?
Yes,
Hello?
we can hear you. Thank you. You're good.
Okay, I'm sorry about that for the technical difficulties. So, okay, starting over, we'll jump right into it. So a little bit about EAB. What is EAB and where does it come from? So emerald ash borer is a metallic wood-boring beetle that feeds almost exclusively on trees in the genus Fraxinus, so our ash trees as we know them, and it's native to northeastern Asia, so mainly northeastern China, Korea, Japan, and parts of the Russian Far East. So before EAB showed up in the United States, we really didn't know much about it because it's not a pest over there. The only reported cases of it being a pest are on North American species of ash that were outplanted to parts of its native range. So why has it become a pest now that it's here? Basically, it's the lack of coevolutionary history between emerald ash borer and our North American ash species. So all of our species of ash here in North America are susceptible, and unfortunately EAB is virtually 100% lethal. So in the almost 20 years it's been here, or 20 plus years it's been here, it's certainly wreaked havoc across most of the native range of ash in the United States and Canada. Okay, so here's a close-up of the adult beetle. I usually wouldn't spend too much time worrying about the ID of the adult beetle because you rarely see it, and I can tell you from personal experience working in heavily infested stands, you hardly see it. But for the audience today, you know, where we have potential situations where we have large stockpiles of potentially infested material, it's a good idea to know what the beetle looks like. They are sun-loving, and they tend to bask in sunny spots. So a pile of, you know, ash debris exposed to the sun might be a good spot to see them either basking on trees or swarming and flying around a little bit. There are some other native beetles that are bright metallic green like this, but there's some really good resources online for people to look at to tell emerald ash borer from some of our native lookalikes. But the adult beetle doesn't do too much damage itself. The larval stage of the beetle is really the damaging life stage, and the life stage that gets moved around the most and is the highest potential for transport. So what we're looking at here is an ash log with the outer bark removed, and these are the larval galleries, and you can see where the larvae of EAB has been feeding in what's called the phloem material. So the phloem is the really valuable tissue to the tree where it transports the majority of its nutrients. So emerald ash borer takes advantage of that nutrient-dense phloem material. That's where it feeds, and basically starves the tree from that material. And when these galleries accumulate enough, they'll totally choke off the nutrient supply to pass throughout the tree. A little bit about the life cycle. So we'll start with the egg stage. This illustration is a little bit deceiving. So yes, females lay 40 to 70 eggs on average. They can lay more. They usually don't lay them in big clusters like pictured here, usually just a couple at a time. And on, you know, either a single tree or multiple trees. So a single female has the potential to really reproduce quite a bit and spread her eggs all over the environment. After hatching, the larvae, like I mentioned, they bore through that outer bark and they spend their developmental time feeding in that phloem for either 1 or 2 years. At the beginning of an infestation, when the trees are still relatively healthy, they're able to defend themselves a little bit. So it takes a little longer for those larvae to develop, and it's on a 2-year life cycle. Once populations ramp up a bit, the trees are weakened, and then the beetles can develop a lot faster, and they switch over to a 1-year life cycle. So infestations, you know, get worse the longer they're in place. After completing larval development, overwintering, the adult beetles will emerge in the late spring. One of the hallmarks of EAB is D-shaped exit holes. So the adults will chew those characteristic exit holes through the outer bark, emerge, spend a couple weeks feeding and reproducing until they lay eggs again. And the adults are able to fly. And one interesting thing about EAB is they're genetically programmed a little bit, so females always fly farther than males, and females carrying eggs, fertilized eggs, actually fly further than unfertilized females, so they can actually cover quite a bit of ground naturally. So we'll just go through some of the really trademark symptoms and signs of EAB. So the first is, again, S-shaped galleries, which are caused by the feeding of the larvae. So there's 4 life stages. You can see here, these are some early instars or life stages of the larvae. So they go through 4 stages. So this is probably a 1 or 2. And they've already begun this S-shaped pattern in their feeding, you know, versus mature gallery here. You know, this is a 4th instar larvae, and you can see they really wind back and forth. And they're not always, you know, totally clear, but for the most part, they're going to hold up to this pattern. So they're easily distinguished. Well, not easily. They can be distinguished from other native insects that utilize our ash trees, which again there are some. So always feel free to get a second opinion if you think you see something, because it can be confusing. Again, this won't be too much use for, solid waste facilities where the material is being brought in, but, if maybe a good thing for personal reference, out driving around. But, as the larvae continue to weaken the tree, the tree loses the energy reserves to support, put out and support a full canopy. So you'll see thinning canopies like this a lot. This can be tricky. A lot of times we're looking at roadside and urban ash trees, which, tend to look to be in pretty poor health to begin with. So a lot of times the symptoms of EAB can be masked, and, it's easy to disregard urban trees or roadside trees as not having EAB when there's a chance that they might. Again, similar epicormic branching. So as the tree loses energy reserves, it tries to put out more leaf surface to build up its energy stores and capture some more energy. Real common in, urban ash trees, again, like you see here. Obviously these are sidewalk trees, but these could be infested, but you do get these epicormic sprouts, sometimes without EAB, certainly, but a good symptom to look for. One of the most important symptoms we rely on for detection is woodpecker damage. So you can see here on the right, how woodpeckers have gone up and down the boles of these trees and systematically removed flakes of bark to reveal this really characteristic light blonde color, as it's referred to. There are some other phenomenon you see here, where bark sloughs off of trees and leaves smooth patches, but you're really going to want to look for that color. And again, an advantage of solid waste facilities, being able to observe ash material, that's already processed and on the ground. You can get a close-up look at this stuff. So in addition to having that bark removed, here's a really good example. You can see, where the woodpeckers come in, remove this bigger chunk, but here's the actual cavity where the EAB larva was that the woodpecker extracted it, and again right there and right there. So you want to make sure, if you're suspicious of EAB, you have those two kind of characteristics coupled together: the big flake removed, but a clear hole where a larvae has been removed from the inside of the tree. Also bark splitting, so the bark overlying these galleries tends to die in older trees after they've been attacked for a while. Logs coming into solid waste facilities, if you're at this point, there's a good chance that the handling is going to be knocking a lot of bark off of those logs coming in. So you might be able to see some exposed galleries where the bark has, first split and then been, further knocked off from the handling process. And then finally, the D-shaped exit holes. So if you look at this beetle in profile, it's perfectly D-shaped, and insects are quite efficient, so they don't waste any time chewing a larger exit hole than they need. So yeah, again, there's a lot of native ash borers that have exit holes that can be confused, but that real flat edge on one side that makes that D shape is EAB. And then real quick, so, why is this a big deal? What do we have to lose? Quite a bit of ash in Vermont, not as bad as some states, but about 5% of our forest resources are about 160 million trees over 2 inches diameter. So anything over pretty much the 1 inch mark can be infested and killed by EAB. Usually they don't rely on trees that small, but certainly this 160 million figure is a good estimate of the number of trees that could be infested here in Vermont and, ultimately will be killed. So that's our forest resource. But again, EAB is going to be a huge urban problem in Vermont, and you can see it'll vary by what community you're in. But certainly, there's communities that are planted extremely heavily to ash, and these are the type of materials that are going to be transported to solid waste facilities because they can't necessarily be cut and left. So there'll be a huge influx of material as we go here. So One little thing about population dynamics here. So here you can see, a model of the invasion wave. So early on, very low populations, hard to detect, but we have an exponential growth curve. So after a couple of years, the population really begins to take off here, about the 5-year mark. So, and usually we don't even know that EAB is present for a couple of years. So, and then we have the mortality wave. So this next line going on here is the mortality. So after the infestation builds, you can see mortality tracks it pretty closely. And yeah, once we hit that 5-year mark, we're really going to start going up in terms of mortality in state here, all the way up to pretty much essentially 100% with a few maybe exceptions. But yeah, we're probably already close to the where this curve begins. We've just discovered EAB, but it's probably been present for at least a year or two, or possibly 3 or more. So yeah, we're getting close to where situation will get critical here in Vermont. Okay, and with that, I'll turn it back over to Paul. Sorry for running over.
Set. Okay, so I'm going to talk a little bit about the spread of EAB and some of the efforts that we're making to try to slow that spread. Mike mentioned that we didn't know a whole lot about EAB in 2002 when the insect was first discovered. But one thing we have learned, and learned fairly quickly, was that stopping the spread of the insect and eradicating the insect are not a possibility. There were efforts in the Midwest in early infestations where there were attempts to do that, where all ash trees in an area were cut. As soon as they got done cutting those trees, they found the insect had spread beyond those boundaries. So we've been able to, Vermont's really, because we're so late in the game, we've really been able to take advantage of what lessons were learned in other states over time. And one of the things we learned was, as I mentioned, eradicating the pest isn't an issue, or isn't an option. And really, county by county quarantines haven't done much other than result in a lot of bureaucracy. Really haven't done much to slow the spread. So what we decided on was to adopt a course of action that was more along the lines of education and promoting some voluntary best practices to help contain the spread of the insect as much as we could, as long as we could, in order to give landowners and municipalities more time to plan and a chance to react. And what we've kind of dubbed that program is slow the spread. Mike mentioned the numbers of ash trees. Just the stumpage value, the value of the standing trees to landowners, if they were to cut those trees for saw logs, is in the hundreds of millions of dollars. And that's not looking at all at the value and the cost of dealing with urban trees. So let me. There we go. So, just kind of cover a little bit about the spread of the insect. We mentioned it was first detected in Detroit in 2002. It spread across North America. This map is going to show where it is in the U.S., but not in adjacent provinces in Quebec. But let me just run this video. So this is what it's showing is the detections on an annual basis between 2002 and 2017 or 18. And you can see how quickly it's spread over those 15 or so years. The other thing to note is that you'll see these little spots popping up way distant from the original infestation. We know that EAB can move 1 or 2 miles a year on its own based on its ability to fly. But then we're seeing these infestations pop up great distances away. That one in the Denver area is one to note. Somehow those insects are being helped along their way. And, you know, one of the ways that that's happening is through people moving material. And you know, firewood is one of the main culprits. This, you know, we've got here a pile of firewood that's been delivered to a business, and so you can't see it in this view. A lot of this material was infested with EAB. You know what? I heard one person say one time that, you know, EAB moves 1 to 2 miles on its own by flying and 65 miles an hour down the road when somebody's moving it. So it can be moved very quickly, and really human-assisted movement is one of the big issues that we're having. There's the S-shaped galleries in that pile of firewood. So our slow the spread recommendations have been developed in conjunction with the Agency of Agriculture, the USDA Forest Service, and the USDA APHIS. And like I mentioned before, they're voluntary guidelines, best practices intended to help us minimize the potential for spread. Guidelines have been targeted to landowners, loggers, tree care companies, sawmills, firewood producers, anyone that regularly handles, stores, or processes ash material and has the potential to move the insect without due care. It's important to note that these are recommended practices. They're not legislated. They're not rules. You know, there is no enforcement authority. They only apply to the infested areas. And you see in the map on the right-hand side here, there are red and yellow blobs. Each of those blobs represents a radius around a point. So the red blobs are 5 miles from a known detected point. The yellow blobs are a 10-mile radius. Our recommendations apply to that whole area. So anything within the red or yellow is where we're applying the slow the spread recommendations. And generally, there's been differences in the recommended practices depending on the seasonality, and which ties in with the biology of the insect. The insects fly generally between May 1st and September 30th. So our recommendations in general are a little different for that flight period during the summer and fall months from the non-flight season, when the insects are essentially just hanging out in the woody material. So the recommendations that we have for solid waste facilities and composters are really pretty straightforward. And we've developed them based on whether your facility is inside an infested area or outside of an infested area. Essentially, we want to try to keep potentially infested material within the infested areas. So you know, they're very basic. Keep the ash material inside the infested area. Chip or grind material before it actually leaves the infested area. So if you're shipping stuff to a power plant, for example, for fuel, you know, you're going to be chipping and grinding that material anyway. Just do it before it actually leaves the infested area. Some solid waste facilities we know have are properly permitted to burn material. That's a completely acceptable method for eradicating the insect as well. And the real key thing is not to let anybody take firewood from inside the infested area unless it's been heat treated. Again, if you're outside the infested area, pretty straightforward. You know, having a handle on knowing where the infested areas are and don't accept any unshipped or unground wood from the infested area. Basically, it's going to mean, you know, quite a little bit of questioning of folks bringing in material just to know that they're not bringing it from an infested area. It's probably only going to be an issue for folks that are very close to the infested areas. Nobody's really going to want to move that stuff very far if they don't have to. And if the material is from within the infested area, you know, our suggestion is to direct them to a facility that's inside that infested area. You know, a few additional things to consider. You know, I mentioned timing, flight season being from May 1 to September 30th. You know, if you've currently got woody material on site and you don't know if it contains ash material, ideally chipping or grinding that before the flight season, the 1st of May, would kill any of the insects that might currently be in that material. You know, beyond that, this is going to take a little bit of education of your staff. You know, utilize the posters that have been provided, and you know, we're more than happy to send additional copies of those out, and talk to the folks that are using your facilities about what their options are. If you want to learn more about EAB or slow the spread, VT Invasives, the website on the bottom of the page here, is our go-to website for information on EAB. The latest infested area maps will always be on that site, and there's an opportunity there. If you see something that's suspicious, you can report that insect through the website. And incidentally, that was actually the way we received the first reports of EAB in the state, where a forester who was doing some work on a piece of private property found what he felt was suspicious information, suspicious trees, and reported that through the site. So I'll turn it back over to Buzz to wrap up.
Thanks, Mike and Paul. Appreciate that great presentation. So just if there are any questions, we haven't had any yet, but if anybody has any questions, now's the chance. Otherwise, again, you can email any one of us for follow-up questions. We had put out a guidance document with the original invitation for the webinar, and we've tweaked it slightly since then, and that's on the VT Invasives website. I'm also going to just send it out to all the folks that we emailed the invitation to. And we do have, Paul had mentioned, we do have these laminated posters. We sent a mock-up out there, but we have 125 posters. We'd love each facility, and there are about 60 or 65 wood managing solid waste facilities out there, to hang one of these posters up at their facility, maybe at the attendance booth or the scale house, and let people know what's expected of them when they come in. So I will also send out at least one copy to every facility that we have. And again, we have extras, or if you want some for some other places in your town or solid waste management district, feel free to let me know, and we can always print more if we have to. Still no questions right now?
There was one question, whether or not we would post the recording of this, and we will share the recording of this webinar once we're complete. We'll post it online, and Buzz, I think, is going to send a link out to it as well.
Yep. Anything else, Paul or Mike? Follow up? Okay. Thanks, everybody. Appreciate your attention. Hope you learned something, and hope we could slow the spread of EAB. Have a good day.
Thank you.